In this video, we're going to watch a presentation about learning about equivalent equations. So that's our DLO for today, so go ahead and write that down. This word equivalent, the beginning part of it kind of sounds like equal. So equivalent just means things that are equal to each other. So today when we talk about equivalent equations, we're talking about two equations that are equal to each other. So here's the definition of equivalent equations, which I do want you to write down in your notes. It says equivalent equations are the equations that have the same solution. So if you solved one equation and then you solved the other equation, they should both have the same solution. Looking at these examples down below, I see x minus 6 equals 5. Well, if I solve that equation for x, I have to add 6 to both sides using the addition property of equality. And when I do that, I get x equals 11. The equation right next to it, I have to do the same thing. I have to add 11 to both sides using the addition property of equality, so I get x equals 11. So because those two equations both have the same solution, it means that they are equivalent to each other. And it should be pretty obvious to see that if you look at this first equation here, if you had used the subtraction property of equality to bring the 5 over to the left-hand side, you would have gotten x minus 11 equals 0, and you would have seen that it was in fact equivalent to the first equation. The second two equations down here are also equivalent to each other. If you solve the first equation for a, you use the division property of equality to divide both sides by 32. And you say that a equals 8 over 32, which is also equivalent to 1/4. So a equals 1/4. And if I solve the second equation over here as well, I can multiply both sides by 4 using the multiplication property of equality. And I get a equals 4 over 16, which is also equivalent to 1/4. So these two equations are also in fact equivalent to each other. So here we have an example. It says if 4 times 7r minus 3 equals 14, what does 7r minus 3 equal? Well, you should notice that we already actually have a 7r minus 3 in the first equation. So because they're asking us what that equals, in that first equation I should just be able to isolate 7r minus 3, or get 7r minus 3 by itself, and then I'll be able to find out what it equals. And I will have come up with a different equivalent equation. So let me write this first equation again. It says 4 times 7r minus 3 equals 14. And then I'm going to isolate 7r minus 3 by dividing both sides by 4, because right now 4 is being multiplied times that quantity, so I'm going to divide it using the division property of equality. So I get that 7r minus 3 equals 14 over 4. And they both have a common factor of 2, so I can simplify that, saying 2 over 2 equals 1, and therefore 14 over 4 equals 7 over 2. So to answer their question, what does 7r minus 3 equal? Well, 7r minus 3 equals 7 over 2. And that is an equivalent equation to the one we had up at the top. Moving on to the next slide. Here it says which equation is equivalent to 2x minus 2, 2 times x minus 2 equals 5 times 2x plus 1. So in this equation, we can simply solve the problem, or at least start to solve the problem. And you'll see we don't actually have to completely solve it, but we'll go most of the way to solving it. So the first thing that I see is I see some distribution that we need to do. So I see a 2 times some parenthesis quantity. So I'm going to go ahead and write my problem again over here. 2 times x minus 2 equals 5 times 2x plus 1. And so if I distribute on the left-hand side, if I distribute my 2 to both of these terms, and on the right-hand side I distribute my 5 to both of these terms, let's see what I get. On the left I get 2 times x is 2x, 2 times negative 2 is negative 4, and on the right-hand side of the equal sign I get 2 times 2x is 10x, and 5 times 2x is 10x, and 5 times 1 is 5. So just like we did last week in our lecture, we were talking about how if we have if we have variables on both sides of the equation, we can draw our river. You guys remember talking about the river last week? And so if we're going to draw our river, I'm going to go ahead and draw a river straight down from the equal sign. And I want to bring all of my variables to one side. And I want to keep them positive, so I'm going to bring the 2x over to the right-hand side using the subtraction property of equality. Whatever I do to one side, I have to do to the other. So I get negative 4 equals, these are additive inverses, that's why they added to 0. I get negative 4 equals 10x minus 2x, that's 8x plus 5. Alright, so now let me look at my choices over here on the left-hand side. I have these 3 choices that I'm looking at, and I don't see that any of those looks like my equation yet. So I'm not going to stop here, I'm going to keep going, and I'm going to keep going to solve it. So looking back over here again, I have negative 4 equals 8x plus 5. So now I'm trying to isolate my variable, so I want to subtract 5 from both sides. Again, using the subtraction property of equality. These are additive inverses, so they're going to cancel to 0, or I should say add to 0. On the left-hand side, we have negative 4 minus 5. So 2 negatives, when you're adding them together, you get a bigger negative number. So negative 9 equals 8x. And I want you to stop here and notice something. Now, we could keep going and we could divide both sides by 8 and get that x equals negative 9 over 8, but this problem is not asking us to find out what x equals. It is asking us to find out an equation that is equivalent to the one given at the beginning of the problem. And so now if I look at my answer choices again, I have found one, in fact, that is equivalent. Negative 9 equals 8x is the same equation as the original one, because I showed you here that just doing simple equality properties or properties of equality, I can get my equation from the beginning to look like the same equation that I have boxed here, negative 9 equals 8x. So these two equations are in fact equivalent to each other. Now, this is nice when this happens, when you don't have to actually solve it all the way through. You can find a match before you're finished solving it. Sometimes, however, it's not that easy, and so in this next example, you'll see that here we have an equation, 3 times x minus 5 equals 4x. And so we're going to start to solve it again the same way that we did the last problem. And we're going to hope that we can find a match somewhere along the way, but you'll see in this one that it doesn't necessarily work out that way. So if I write my problem over again, I have 3 times, let me use a smaller marker, 3 times x minus 5 equals 4x. So the first thing I want to do is I want to get rid of those parentheses by distributing this 3, the distributive property. 3 times x is 3x. 3 times negative 5 is negative 15. And that equals 4x. Now again, I have variables on both sides of the equation, so I want to draw my little river. There you go, that one even looks like a river. I'll draw my little river down from the equal sign so that we can make sure that every time we go across that river, we're using our properties of equality to do whatever we do to one side, we do to the other. So I see my 3x on the left-hand side, I see a 4x on the right-hand side. If I want to keep my variables positive, I'm going to subtract 3x from both sides. So minus 3x on the left, minus 3x on the right. These are additive inverses, so they add to 0. Negative 15 equals 4x minus 3x. Well, 4x minus 3x is 1x, or just x. So lo and behold, I have actually solved my problem, and I know what x equals. I know that x equals negative 15. But if you look at our answer choices over here, none of these ever looked like anything that we had in our equation. So none of our steps that we were solving ever looked like any of these. And so sometimes that'll happen where you won't get a nice, easy answer. And so what happens here is that now we know our solution is x equals negative 15. If you look back at the very beginning of your notes, it has a definition of equivalent equations. So go back and read that really quick. And you should be reading where it says equivalent equations are equations that have the same solution. So if I know the solution to this equation is x equals negative 15, then I should be able to solve these equations over here to figure out which other equation also has a solution of x equals negative 15. So like I said, sometimes it's not so easy. Sometimes you have to do a little bit of extra work. So let me solve the first one. The first one is 3x equals negative 45. Using the division property of equality, I'll divide both sides by 3. So I get x equals, those are multiplicative inverses, x equals negative 15. Well, voila, I found my answer right away. It was A. They both have the same solution. I could go through and I could solve all of the other possibilities as well, B, C, and D, but you'll notice that the only one that has the same solution as our original equation is in fact A. Again, that won't always be the case. They won't always be as nice to you. Maybe sometimes it'll be selection D, so you have to go through all of them and solve all of them before you find your answer, but in this case it was nice and easy for us. It was the first one. So, to answer our question one more time, which of the following equations is equivalent to 3 times x minus 5 equals 4x? Well, we solved that equation and got that x equals negative 15, and we started solving our answer choices and found that A had the same solution, so 3x equals negative 45 was equivalent to that original equation. Here's some for you guys to try. You can just write equivalent equations to these. Now, the nice thing about equivalent equations is you can kind of be as creative as you want with them. You can add numbers to them as long as whatever you add to one side you add to the other. You can subtract using the subtraction property of equality. You can multiply, you can divide, as long as you keep under that rule that whatever you do to one side you have to do to the other using your properties of equality. So your answers to this can vary. I'll just show you some of the ones that it could be. So I just, for some of these, just simplified them a little bit. So for the first one, I just added 4 to both sides. So I got 2x equals 4. Again, yours can look different than mine. It just said find a equivalent, or I should say an equivalent equation. So there's one. There's many, many equivalent equations. For the second one, I just used the subtraction property of equality to subtract 2 from both sides. So I got 7x equals negative 2. Again, your solution could be different. That's just one equivalent equation. And for the third one, I just distributed the 3. So I got 3x minus 15 equals 0. And so again, that's just one equivalent equation. There are many, many, many different answers to this question. But these are just some possibilities for you. Last slide. Sometimes in various contexts within a math class, or even other classes for that matter, you'll be asked to find mistakes in another student's problem. So it's your job to analyze their work and figure out where they went wrong or figure out where they made a mistake. And so sometimes it's difficult when you're looking at their work. It's difficult to find out where their mistake is, because you just you kind of understand their thought process, and then sometimes the mistakes kind of get pulled over and you don't really see them very much. And so what I would suggest for you, in order to help yourself find mistakes in other students' work, I would find the original equation and then solve it yourself and find out what your solution is, and then go back to their solution and try to compare your two answers to figure out where they made their mistake in their problem. So for example, I'm going to go ahead and write a problem up here, and I want you guys to try and find out where I made a mistake. Alright, so there's my answer. I did make a mistake somewhere. I want you guys to go back and find it. Put it in your notes, put a big circle around it, and then tell me where my mistake was. Alright, that's all for today.